To begin, Hurricane Juan was a Category 2 storm that left behind much destruction at Point Pleasant Park in Halifax, Nova Scotia. The park holds much importance, not only with the flora it houses, but also to the Mi'kmaq people, as they designated it Amnu Tukadi, or the Place of Spirits. Previous research originally classified the park as belonging to the Spruce, Fir, Pine, Maple, Birch Association of Forests. Shortly after the storm, Neely and colleagues conducted a survey of the disturbed park and found that the majority of the park was composed of red spruce, maple, white pine, and some balsam fir. Most recently, Keyes found that the forest exhibited vegetation that was dominated by white birch, red maple, and bracken. The main issue with the above studies is that the classifications used are discontinuous and range in specificity, making it much more difficult to analyze the actual changes in biodiversity at the park. This is where we come in. Our aim was to further examine the succession at Point Pleasant Park. More specifically, we wanted to quantitate the changes in species diversity from year to year to estimate the stages of succession and the progression towards the climax community. To do so, we collected data from randomized quadrats from across the forest and estimated percent cover for ground flora inside these quadrats. Trees were subject to diameter at breast height measurements. Our research aimed to answer three main questions. First, how has the forest community's species diversity changed over time? Well, we hypothesized that species diversity has increased since the hurricane. If this is the case, we predict a positive relationship between Shannon Diversity Index, or H prime, and time since the hurricane. Our null hypothesis is that there was no change in Shannon Diversity Index since the hurricane. Second, how has the density of the dominant species in 2003 and that of the species in 2024 changed over time? We hypothesized that the currently dominant species must have a higher rate of density increase relative to the former dominant species. If this is the case, we predict that the linear rate of increase of the 2024 dominant species will be greater than that of the 2003 dominant species. Our null hypothesis in this case is that there was no change in density for both species since Hurricane Juan. And last, how has the species richness in the forest changed over time? Well, we hypothesized that species richness has increased since the hurricane. If this is the case, we predict a positive relationship between the species richness per unit area and time since the hurricane. Our null hypothesis is that there was no change in species richness since the hurricane.
In order to examine the secondary succession occurring, study sites were used. Each study site was 20 meters by 20 meters and dispersed throughout Point Pleasant Park, as you can see in the figure here. Trees and ground flora were examined to determine the changes in the forest community during its secondary succession post-hurricane. For trees, all living trees that were greater than or equal to 2.5 centimeters in diameter at breast length, or DBH, were measured at each study site and identified. This gave us an estimate of the amount of wood in a stand of trees. On the other hand, for the ground flora, the percent cover of each species of group of flora was sampled using 12 of the 1 meter squared wooden quadrats. The selection for the location of each quadrat was chosen at random, and by this I mean the center of each quadrat was determined by a ball being thrown behind someone's back, and wherever this ball landed was to be the center of the quadrat. And this ensured some unbiased randomness for each sample. As well, this was repeated for each site. And finally, a linear regression analysis was chosen for this study as it best represents the change for the forest community with respect to time.
We used a regression analysis to assess if there was any correlation between Shannon Diversity Index and time elapsed since Hurricane Juan. This is depicted in Figure 2. We found that there was a significant positive relationship between Shannon Diversity Index and time in years since the hurricane. This result supports our prediction, and we can reject our null hypothesis. We can then use the regression equation provided in the figure to predict the diversity index based on the year. From the data, we predict that diversity index will increase as we progress towards the climax community. The increased species diversity could be attributed to the takeover by numerous intermediate species from the pioneer species during succession. However, this rate of increase may halt as we near the climax community and the dominant species outcompete their counterparts.
These graphs represent the changing density of red spruce trees and red maple trees in Point Pleasant Park after Hurricane Juan using data collected from 2003 until 2024. The graphs show an overall trend of increasing density for both species. The red spruce tree had an increase in variance of 12.18% in 2024 in comparison to 2003, while the red maple tree had an increase in variance of 15.49% in 2024 in comparison to 2003. And then in 2015, the red spruce had a large increase in density compared to the red maple trees. However, the red maple density quickly caught up over the next 5 years and had a higher density than red spruce around 2020. This spike in density levels for the red maple allowed for it to take over as a dominant species over the red spruce. Therefore, as predicted, the red maple has a higher rate of density increase, making it the dominant species in 2024, relative to the 2003 dominant species of red spruce, which has a lower rate of density increase.
We used linear regression to examine the species richness of Point Pleasant Park over time by collecting data on a number of species within a certain area over several years. Within Point Pleasant Park, there was a significant positive correlation between the species richness in years since Hurricane Juan in 2003, figure 5, indicating that as time passes, species richness tends to increase. Due to the positive correlation between the species richness and years past, we reject the null hypothesis and favor the alternative hypothesis that species richness has increased since the hurricane. The results show that species richness tends to increase as years past increases, meaning that as the forest moves towards its climax community, due to the positive correlation between the two variables, the species richness will also continue to climb. Comparing the data over time, the average species richness is nearly 4 times more per 400 meters squared in 2024 than it was in 2004, figure 5. In a similar study by BIOl, it was found that secondary succession initiated by Hurricane Fran had accelerated the succession process of pine forest in North Carolina to a later successional stage. This absence of the dominant in our larger species allowed for less dominant flora to grow and develop in the uninhabited areas caused by these hurricanes. Within the linear regression, r squared is 0.6051, therefore time passed in years explains 60.51% of the variation in species richness. As the forest grows and matures, the continuous rate at which the species richness increases will begin to slow until it stabilizes at equilibrium once the species richness reaches its climax community. Based on the Shannon Species Diversity Index, the trends of growth between the red maple and the red spruce, and the species richness in Point Pleasant Park observed from 2004 to 2024, we predict that the Acadian forest is currently in mid-stage succession due to the continuous rate of regrowth of the forest. The positive correlation between time and regrowth of the forest ecosystem is a significant indicator of successful secondary succession occurring, and the ecosystem of Point Pleasant Park recovering naturally. Due to Point Pleasant Park being an urban park, human influence can greatly affect succession due to the possible anthropogenic additions of invasive flora. There are several management reports that suggest removal of exotic species will allow for better growth in the native species, Turchin 2016. Between the years 2018 and 2021, the average number of species per 400 meters squared decreases, as seen in figure 5, despite the continued positive linear regression. This decrease in species richness could be explained by the removal of invasive species, resulting in a lower diversity of plants, providing the native species better opportunity to continue to regrow. Succession may also be affected by human infrastructure, altering the expected natural development of many species due to the additional stressors, Burley et al. 2008. This phenomenon is called fragmentation, which occurs when specific areas of the ecosystem are separated into smaller sections. This can influence the species in that area's abilities to develop further and continue to regrow and repopulate the area. Red spruce density, despite increasing on average over time, has remained consistently low, under 5 individuals per 400 meters squared, in several observation sites, figure 3. These continued low numbers of individuals could indicate that those areas are fragmented by human pathways or areas throughout the park, limiting the ability for the red spruce to develop and populate in those sites. Cultural burning is an indigenous culture practice that can significantly improve an ecosystem's diversity and management of resources. These intentionally lit, controlled fires aid to promote ecological diversity, as well as being a way for many indigenous communities to spiritually reconnect with nature. The philosophy behind cultural burnings refers back to the concept of fire as medicine, National Park Service 2024. Similar to how modern medicine is prescribed, it is only applied in small amounts to maintain the systems and abundance of the ecosystem, while also improving soil quality and allowing the land to become more resilient. Use of small controlled fires within Point Pleasant Park could aid in the continuation of the forest's regrowth into maturity while promoting species diversity and abundance.
We would like to thank Professor Alison Schmidt and TA Tegan Robinson for assistance and guidance on this presentation, as well as assistance with fieldwork and data collection at Point Pleasant Park. In addition, we thank the Halifax Regional Municipality for the upkeep of Point Pleasant Park and accessibility to it. This work was also supported by Dalhousie and the BIOl2060 Introductions to Ecology Lab and Lecture.